Alright, yo, so here's the Folium Problem, mate. Hold up. Alright, so let me just draw the graph over here. And the question asks to find the point in the first quadrant where the tangent line to the folium is horizontal. Right, so let's first start by implicitly differentiating this function. So implicitating will be 3x squared, and then it'll be 3y squared. But since we're deriving y, then we need to do dy dx because it's implicit differentiation. And then 3xy will do product rule. So it'll be just 3, and then dy dx because we're differentiating y. Then 3. Oh no, never mind. I was supposed to keep y whole over here because we differentiated x. It's 3. We differentiated 3x. It's 3. Then just y over here. Then it's going to be 3x. Then we're going to differentiate y. So it's dy dx. All right. Now that we have this, we can isolate our dy dx's. So 3y squared dy dx minus 3x dy is going to equal to 3y minus 3x. And then I bring it out of the brackets. It's just going to equal this. Now, we're going to want to, now in order to find our little point over here, in order to find our little, or like this point over here, we're going to need to find a y value. Or we're going to need to find a y value, or an x value of this point over here, so that we can then plug into the function and get our other point, either an x value or a y value. In this case, it's easier to isolate the y because the y isn't squared or anything. And also, because this line is horizontal, because this line, like this tangent line over here is horizontal, we know that the slope is 0. Therefore, dy dx, the change of y respect to x, y is not changing. It's not going up or down. It's just constant. Therefore, the change of y with respect to x is 0. So first, let's try to get our function to isolate y because we want to find the value of y, right? So y would equal to dy dx 3y minus 3y squared minus 3x. Wait, actually, it would just be y squared minus x, and then plus x squared. Since we factored out all the 3's, so then now we just have our singular y, right? Then we can plug in 0 over here. So since dy dx is 0 and it multiplies with this, that whole thing will cancel out and y would just equal x squared. Y equals x squared, great. Now what are we going to do with this? In order to get both our points, in order to get both our y and x points, then we're going to try to make a system of equations. So we got our first equation here, y equals x squared. And we got our second one, which is actually going to be the equation of our folium. x3 plus y3 equals 2 3xy. So let's plug in our y into our folium. So since y equals to x squared, we have x3 plus x squared to the power of 3 equals 3xy. So then we'll have x3 plus x6 equals, oh wait, I forgot to plug in, it'll be x times x squared. Then it'll be x3 plus x6 equals to 3x3. So it'll be 0 equals to 2x6, no, 2x3. No, wait. It'll be x6 minus 2x3 equals to 0. Then we can factor out x3, and it'll just be x3 minus 2. Now we have two x values over here. We have x equals to 0 and x equals to cube root of 2. Now, x equals 0 because if we were to plug 0 into this term, it would make the whole thing 0, and then, 0 would equal to 0. And if we had cube root 2 over here, 2 cube root of 2 to the power of 3 is just 2, then 2 minus 2 will also equal to 0 minus 0 equals 0. Therefore, these two are the solutions. But if we go and look back at our folium, if x equals to 0, y would also equal to 0, because that's just where the point of the folium is when x equals to 0. Y would also equal to 0, right? If we were to plug x equals 0 into this, y would just have to equal 0, and that's not the point we're looking for, because the question explicitly states that the point is, at that point is where the tangent line is horizontal, right? You could argue that the tangent line could be horizontal here because, it does slightly go this way, but then the graph intersects itself there. So it's going this way and it's going that way. Therefore, there is actually no slope at this point because there is just two lines intersecting each other at 0, 0. So because of that, we can now determine that cube root 3 root 2, well, cube root 2 is going to be over here. So now that we found our x coordinate, we're now going to try find our y for that. So let's plug that into our function. So let's plug this back into our folium function. Or actually, even better yet, since we did have a system earlier, we could actually just plug this into our y equals x squared, since the system of equations should satisfy both points. So y would equal to 2, 1, 3, 2. Therefore, y will equal to 2 over 3. Just give me a second, just verifying the answer. Yes, exactly. According to my Desmos, this is the exact solution. So finally we can therefore deem our points to be 2, 1, 3 and 2, 2, 3, and that is our answer.